Hello everyone, this is Professor Collins and we're going to be going over an Excel workshop today. So today in the Excel workshop we're going to go over these formulas here, specifically standardized, percentile, rank.exe, percentile.exe, and Countif. Now let's quickly do some review, so just so that we're all on the same page. When I say raw score, I'm referring to the X. This is the value or score within a given distribution. So this is a single score within a distribution of scores. The z-score is a standardized score with a mean of 0 and a standard deviation 1. It's the distribution. So we can calculate a z-score based on a raw score. And then the percentile rank. This is the percentage of scores in a distribution that fall below a given score. And so using raw scores, the z-score formula, and percentiles, we can calculate each of these going back and forth. If we have a percentile, and a mean and standard, if we have a percentile, we can calculate a z-score in the distribution, and we can calculate a raw score, and vice versa, right? So you should be able to do all three of these things within Excel. So real quick, let's just go take a look at these formulas. So standardize, what standardize does is it's basically Excel's way of calculating a z-score. So instead of, you can calculate the z-score on your own by hand, and it's actually fairly easy. But the formula standardize makes it just a little bit easier. The percent rank calculates the percentile rank for X, or for a raw score within a given distribution. So this goes straight from raw score to percentile, right? So it calculates your percentile rank for you for that given raw score. You could also use the z-score. It'll end up with the exact same percentile. And then percentile.exe calculates a raw score with a particular percentile within a range of scores. And what that means is that if you give the formula which percentile you're trying to identify within a raw score, within a distribution of scores, it'll give you the raw score, or the X, that would sit at that exact percentile. And then finally, Countif allows us to count the frequencies of scores given some stated criteria. So if we're interested in knowing, for example, how many scores fall above, let's say, 1.35 z-scores, we can use this Countif formula to identify the exact number of scores that fall above that. All right? So let's dig into this. We have a data set that is taken from the 2014 NFL football season, and this is looking at only quarterbacks. And so we actually have the entire population of quarterbacks, and these are quarterbacks only who had played at least one snap last season, in the 2014 season. And so everything highlighted here is what we'll be calculating. The mean and standard deviation, we need to calculate that. But we can calculate, we'll start with z-scores, percentile ranks, and then we'll use that percent rank function, and then we'll go over two examples of using the Countif function. So we'll be looking solely at yards, and this is, for those of you who are not familiar with football, these are the total number of yards thrown by the quarterback last season, and that's across the entire season. That's 16 games. All right, so you might see some differences in yards per game here. This is what this is, or this top function here, this top category, and the difference is that there may be people who threw for a lot of yards but didn't play all 16 games, for example. So you might see a little discrepancy between these. So we'll look solely at the total number of yards, and we'll be looking at the rank, or the distribution of the total number of yards across all of these quarterbacks. And so right now, what I can do is I can look at how many quarterbacks we have, and Excel's nice because it gives us this little count function down here. So we know that there are 72 quarterbacks in the 2014 season who played at least one snap. So instead of continuing talking about this data set, let's just go ahead and calculate some stuff. So first we want to calculate mean. So I'm going to use the formula average for this. and I'm going to highlight all of my scores. So just a little cheat, what I like to do is I like to highlight the top cell, and I'll hold Shift and Control and push my down key or my down arrow, and that'll highlight all of those scores. And then I'll continue holding Shift and close my parentheses. And that'll give us the average. All right. And actually, you know what I'm going to do just to make this a little bit easier? I'm going to freeze the panes right here so we can continue seeing all of these even when we're scrolling. So now I want to calculate the standard deviation. So I'm going to start typing out STDEV. And in this case, I want the standard deviation of the population. And the reason I want that is because we actually have the entire population of quarterbacks who played in the 2014 season. If I didn't have all of those, we would only have a sample, and I'd want to use STDEVS. Right? So in this case, I want to use STDEV.P, which the .P stands for the population. So we'll do that. Same thing, calculating the standard deviation for all the players, or all the yards. And you can see we have a fairly large standard deviation. So this distribution is really, really large. All right. So now, using mean and standard deviation, we can start calculating z-scores. So there's two ways to do this. The first way is just the standard formula. So the z-score formula is x minus the mean divided by standard deviation. That gives us a z-score for Drew Brees of 1.903. The interesting thing is, or the cool thing about Excel, is we don't have to calculate all of these by hand. We can use standardize. So we use the standardize function, and as you can see, it uses the same three elements, x, mean, and standard deviation. So it's just calculating it for you. So we'll do x, comma, mean, comma, standard deviation. And because Excel is relational, we're going to want to make sure that our mean and standard deviation do not go anywhere, but that our x follows our formula. And you'll see what I mean in a second. So what I'm going to do to hold those two cells stable is put dollar signs in front of them. And you can see where I did the dollar signs here. I'm going to hit enter and copy and paste this formula all the way down. So now we'll have a z-score for all 72 quarterbacks. So there's a couple ways I can do this. The easiest way for me is I'll hover my cursor till it makes a little black plus sign in the bottom right hand corner, and I'll double click. And it just automatically does all of that stuff for me. So as you can see, we have z-scores for the highest ranked quarterbacks, very high, and the lowest ranked quarterbacks, obviously, very low. All right. And the reason you don't see Drew Brees being 100 and 100, or excuse me, really, really high on the z-score distribution, and let's see, Tavares Jackson being extremely low, although these are fairly low, it's because their standard deviation is gigantic. It's a really large standard deviation. Alright, so now what we can do is we can calculate our percentile ranks. So this will give us the percentile for every single score. Alright, so what we're going to do here is we're going to start typing in percentile, and we want the one that says percentile rank.exe. And our array is our distribution. So we're gonna want to get our distribution of total yards. So that's our total distribution. Then we're gonna want our x, which is the first score, right? So x in this case is our raw value, and it's also asking for significance. We're not concerned about that right now. So we're gonna go ahead and just leave that blank and close the parenthesis, and hit enter, and that gives us our percentile rank of Drew Brees. And we can do the exact same thing like we did with z-scores. And we can double click in the bottom right hand corner, and it gives us the percentile rank for every single person. And I just made a mistake, and so this is an interesting piece of information, right? Because Excel is what's called relational, that's why I had in the z-score, oops, let's not do that. That's why when calculating the z-scores, I had to put those dollar signs, and I forgot to do that. So I'm going to have to do that. and we'll want to do that for D73. That's hit the right button, and D2, right? And so we'll just want to go ahead and double click that again, and it'll highlight them correctly, right? So if I didn't do that, it would the array would continue following the copy down, and so we wouldn't be capturing all of our yards. All right, so now that we have that, we have our z-scores and percentile ranks. So now let's say we don't have precisely a 65th percentile. We have 65.7 percentile, and we have 64.3. But we don't have an exact 65th percentile. And we want to know the raw score of what would be the 65th percentile. We can calculate that by hand, or we can use this function called percentile. We're going to do percentile.exe, and again we're going to want our entire array or our distribution. And then we're going to want k. In this case, k stands for the percentile, and it should range between 0 and 1. And so in this case, we're looking specifically for the 65th percentile, so I'm going to put 0.65, which will represent the 65th percentile. Close my parentheses, hit enter, and that gives us a score of 2,501. So if we go find our 65th and 65.7 and 64.3 percentile, and I'll just highlight these. Oop, wrong button. Our 65th percentile, let's make that a little bit lighter. Our 65th percentile should sit right in between these two, right? Because it's in the middle of these two percentiles. And as we see, 2,501.9 yards does sit between 2,525, 2,483. So that's a quick and easy way to identify a specific raw score that sits at a particular percentile. And we can change this number to be any percentile, 65, 32, whatever you happen to want to identify. All right. So now let's go to our Countif function. And so this one is nice because it allows us to count a particular number of scores within a given criteria, right? And so let's say, for example, that I'm interested very specifically, and I'll scroll over here, in the number of scores that have a z-score of greater than 1.33, right? So what I'll be doing here is, because I'm interested in z-score specifically, I'm going to be using the z-score array, and I'm interested in a particular number of scores, right? So the exact number of scores that are greater than 1.33. So I could easily go here and count these, right? So it looks like this one is the first one, but if your data is not sorted, you'd have to sort it. It just makes it a little more difficult, right? But I can count these by doing this and looking here. So we have 11. This one's less than 1.33, so that one wouldn't be counted. But we can use the Countif function to help us out here. So I'm going to type in Countif, and we're going to want to pick our range. And so for this, it's not called array, it's called range, but it's still the same thing. So we're looking at all of these ranges of scores, and we're looking for our criteria. Now this one's kind of funky because we're gonna enter our criteria as greater than 1.33, but because in Excel greater is identified as a piece of a formula or mathematical formula, we have to put quotations around it. So we'll have greater than 1.33. So we'll do open quotations, greater than 1.33, close quotations, and then close the parentheses. And this should give us 11, which it does, right? So this tells us the exact number of scores that are greater than this score of z-score of 1.33. Now let's say we're interested in percentiles, right? The number of scores that are less than the 33rd percentile. So we could do the same thing, right? We could go find the 33rd percentile, or the one right above it. Let's sort of just kind of take a look here. So this one is the one greater than the 33rd percentile. This is the one less than. So again, we're looking at percentile rank. We can highlight this and we find 24. But if your data is not sorted, it kind of makes it a little more difficult. So again, we're going to use the Countif formula. And we're going to highlight all of our data in the percentile rank this time. And again, we're going to enter our criteria. So equals less than 0.33, close quotations, close the parentheses, and there we go. We have 24, just like we identified. All right, so that's your quick tutorial on Excel and looking at percentile ranks, z-scores, percentiles, and identifying various criteria of different scores. Thank you for watching.